Good afternoon, it's Gene from maverickstar Observatory. I wanted to show you something really important in this video. I want to bring your attention to the date. Obviously you can see it's the 12th 24 2020, but in particular in this, what I wanted to show you, if I can just get rid of that now, I've showed you, is we are looking at current temperatures on our Earth on the W3 map, which is like an unravelled map of the ball that we live on, or the globe. You'll see temperatures in Russia compared to Canada is a lot higher. Just for instance, we're looking at temperatures at -31 there in Canada, just another region there, -36. Over in Russia we can see -40, -40.8, again -43, and so on. The important point here is I'm going to show you side by side the magnetic intensity map, and what you're going to notice is not only are these regions on our planet, like over the northern hemisphere, over Canada and in Russia, very cold regions, but they are also the regions of where the highest magnetic intensity is, and that is also right for the southern hemisphere. If you look over Antarctica, you'll see that there is a lighter purple. Now you know what time of the year we're at, and you know because of the angle with relationship to the sun, obviously the southern hemisphere of our planet at this point in time of the year puts it in the summer, and over in the northern hemisphere in the winter, because as the angle of us travelling around the sun remains at a constant angle, you know, over in the northern hemisphere during the summer we're closer to the sun because we're on the other side of it. Now we're on the other side and we're further away, so northern hemisphere's in the coldest part of the region now, putting us, you know, a little bit further away than the southern hemisphere, and you know that is obviously a good indication of how fine lying our planet is, and therefore how our climate changes seasonally. You know, it's nothing new, it's nothing rocket scientist here, but what the point I'm trying to make here is that if we look at where the highest magnetic intensities are, it is also where the lowest temperatures are on our planet, and I don't think that that is by any coincidence. What I believe is happening over the northern hemisphere right now is, as it's tracking over the magnetic pole towards Russia, it is taking that Arctic climate with it, and you know this could be something of a game changer in the not too distant future, especially when we pass that 40-degree mark and the poles leave the strong field lines of the Earth and go into the weak field lines, and therefore migrate a lot quicker. What we might see is a rapid change of climate over regions of our planet that have never experienced such temperatures. Before I show you the magnetic intensity map and this one side by side, I just want to point out, look at how far south those Arctic temperatures are creeping down now over the northern hemisphere towards the equatorial region. You can see that they're almost on the Gulf of Mexico. You can see also on the right hand side, you know, that Arctic region creeping down further and further into China. One of the most densely populated areas on our planet is over that continent. You know, we've got a big population in Russia, big population in China, and it also extends over to Europe. Where are we going to grow our crops from in the future, is my question. If the regions around the equatorial zones of our planet are, you know, suffering from droughts or even flash floods occasionally, then the northern hemisphere is going to be suffering from Arctic temperatures and frozen ground. We have never had so many people on this planet, guys. You know, it is changing before our very eyes, and you know, I know it's Christmas tomorrow, but you know, that is no reason for any one of us to take what is taking place right now for granted. As human beings, I am disappointed to say this, that we are terrible stewards of this planet, and you know, it is a blue diamond. You know, this planet is the only planet in our solar system that supports life, and it is said that the nearest habitable planet, as far as scientists have been able to make out so far, is so far away that even if we travelled at light speed we would not get there. So let's have a look at these magnetic maps next to these temperature maps, and I think it stands testimony to itself. I think anyone that is logic would look at these temperature regions of lowest temperature on our planet and see that they are underneath the highest intensity of magnetism on our planet and conclude one thing: it is no coincidence. The mechanics of our planet obviously play a part in not just magnetism but also temperature, and it shouldn't come as any surprise to anybody really, because where the poles have been for the last 780,000 years have been over the Antarctic and Arctic regions of our planet, and it should come as no surprise that these are also the coldest regions. But when we see over in Russia that big purple plumage of low temperature, sub-zero low temperature increasing, it just gives us an idea of what we can expect as these poles begin to migrate even more. So here we are, we're looking at both images now. We've got temperature on the left hand side of the screen, on the right we've got magnetic intensity. You can see on the left hand side with regards to temperature over the northern hemisphere, directly over Canada, that there is less sub-zero temperature in range than what there is over the side where Russia is. You can clearly see that. And on the magnetic intensity you can clearly see that the highest intensity is over Russia and the least out the two over the northern hemisphere is over Canada. So that fits. Again, over the southern hemisphere we have a slight plumage of purple showing sub-zero temperatures, and again on that right hand side going up over towards the continent of Australia, you can see the high intensity there ranging in around about 60 nanoteslas. Again in Canada around 60 nanoteslas, but over in Australia 55 nanoteslas, giving us an overall magnetosphere strength of about 50 microteslas. So I think it speaks for itself, guys. If the magnetic North Pole is migrating towards Russia, and we know now why it is and that it is doing that, it is also, by the look of it, taking the Arctic temperature with it. And when it goes over the 40-degree mark, it's going to migrate a lot quicker, which means that there are going to be some regions on our planet which are going to suffer sub-zero temperatures in a rapid movement of the migrating pole. How long that will be during that time is anybody's guess, and anyone that says they know how long it will take for a complete reversal to happen is obviously just using best guesswork, because nobody knows. There's no recorded data of this. So that's where we stand today. I thought it was well worth pointing it out to you guys, because we are at that point of the position around the sun to put us in the northern hemisphere and also the winter season, and we get a clearer picture of what's going on with regards to those Arctic and Antarctic temperatures, and we can make a good comparison with the intensity of the magnetic regions of our planet. So I'll leave it there, guys. It's Christmas Day tomorrow. I want to encourage you to make the most of it while we can, because I really don't think in 3 years time most of us will be sitting around the table with our families. We might be experiencing different things taking place, not just with regards to our climate but our current well-being on this planet. So make the most of it, and enjoy that time with your loved ones. I will mention just briefly, there's a link down there if you want to help support us. Crappiest time of our year for us over here at the maverickstar Observatory with regards to raising funds, but that's just the way it is, isn't it? And with that, I'll say what I usually do. Guys, take care as always. Bye for now.